In this lab video, I'm going to show you how to run a difference of means test in SPSS. In SPSS, this test is called an independent samples t-test. As an example, I will be using the world data set. I will use det as the dependent variable and oil as the independent variable. I will divide the data into two groups based on oil. I will compare the mean of det in low oil producing states, less than 1 million of barrels of oil produced per day, and the mean of det in high oil producing states, 1 million barrels of oil or more produced per day. My null hypothesis will be high oil producing states have the same amount of det as low oil producing states do. My alternative hypothesis will be the mean of det for high oil producing states will be less than the mean of det for low oil producing states. Since there is a less than sign in my alternative hypothesis, I expect there to be a negative difference in means. I will run a difference of means test to analyze the effect of oil on det. Since I am working in SPSS, my decision rules for this test will be slightly different. They will be, if SPSS calculated that there's a difference in means the way I expected, in this case negative, and the significance value for the difference in means is 0.10 or less, I can reject the null hypothesis. I can conclude that the independent variable influences the dependent variable the way I expect. If SPSS does not calculate that there is a difference in means in the way I expected, in this case producing a positive difference instead of an expected negative difference in means, or the significance value for the difference in means is greater than 0.10, I cannot reject the null hypothesis. I cannot conclude that the independent variable influences the dependent variable the way I expect. In order to run the independent samples t-test, you click Analyze, Compare Means, Independent Samples t-test, put the dependent variable in the test variable box and the independent variable in the grouping variable box. In this case, det was the dependent variable, so I move it to the test variables box, and oil was the independent variable, so I move it to the group variable box. Next, you click Define Groups. There are two ways in which you can define groups. If your independent variable only takes on two categories, such as 0 or 1, select Use Specified Values and place the values of the variable in the Group 1 and Group 2 boxes, such as 0 or 1. If you are artificially creating a two-category variable from an interval or ratio level variable, such as creating two groups based on oil, low oil producing and high oil producing, then select Cut Point. The cut point allows you to divide the data into two groups based on a certain value of the independent variable. In this case, I will type in 1 million because I want SPSS to create two oil producing groups, one for low oil producing, less than 1 million, and one for high oil producing, 1 million or more. And click Continue, and click OK. The result of your analysis should be in the viewer window. The first table displays descriptive statistics for your dependent variable for each subgroup of the independent variable. The second table displays the results of the difference of means test. The first thing you need to do is to look at the Levine's test for equality of variances. It tells you which row you should use in the table. If the significance value here is greater than 0.05, then you use the equal variance assumed row. If the sig value is less than 0.05, then you use the equal variances not assumed row. Since the sig value is greater than 0.05, I will use the equal variances assumed row. Next, the mean difference box tells you if there's a positive difference in means or negative difference in means. If you expected there to be a positive difference in means and this value is positive, or if you expected there to be a negative difference in means and this value is negative, then you should examine the sig two-tailed box. The SIG two-tailed test tells you if the difference is significant. If the SIG value is less than 0.10, then the difference is significant. There's a difference in means. You can reject the null hypothesis. You have support for your alternative hypothesis. If one of the following conditions are met, your results are not significant, you cannot reject the null hypothesis, and you do not have support for your alternative hypothesis. You expected there to be a positive difference in means, and this value is negative. Or if you expected there to be a negative difference in means, and this value is positive. Or if the SIG value is greater than 0.10. Now, applying these steps to our example, I expected there to be a negative difference in means. This box here indicates that there is a negative difference in means. Moving on, the SIG value two-tailed here was 0.003. 0.003 is less than 0.10, so the results are significant. I can reject the null hypothesis and conclude that high oil-producing states have less debt on average than low oil-producing states do.